Hello everyone, this is the second video of our assignment, which is the C code of NCR and the MIPS code of NCR. The C code of NCR, you can see here, we have initialized the value of N and R. Then we are doing the factorial N, and we are dividing the factorial N by factorial R into factorial N minus R and placing the result to a new variable which is NCR. Then we are printing the result. And the factorial function, recursive function, here you can see the base case is if n less or equals to 1, it will return 1, else it will return n into factorial n minus 1. So this is the C code of NCR, recursive NCR. And now we will show you the MIPS code of NCR. Here we have initialized the value of n, which is 6, and the value of r, which is 3. We are doing the instruction add immediate, that is by adding 0 with 6 and placing the value to the S1 register. Following the next instruction, we are adding 3 with 0 and placing the result to the S2 register, and again we are adding the value of S1 and 0 and placing the value to the A0 register, which is n. Then we will jump and link to the fact function. You can see the fact function here, and the first instruction of the function is add immediate, which is we are subtracting the stack point by 8. Again we are storing the register RA and register A0 to the stack point. Then we are comparing this instruction by BLE, which means branch less equals to. If the value of A0 less or equals to 1, then it will go to the base function. The BLE function, here you can see I am again saying if the value of A0 is less than or equals to 1, then it will go to the base function. Then it will jump to the recursive function. The base function, here you can see we are loading the value of RA and A0 register to the stack point, and again we are following the add immediate instruction, which is we are adding 8 with the stack point, and again add immediate instruction, that which is we are adding 1 with 0 and placing the result to the V0 register. Then we are going to jump to the RA register. The recursive function, here you can see we are using add immediate function, and this instruction says that we are subtracting 1 from the value of A0 and placing the result to the A0 register. Then we are again jump and link to the fact function. The next instruction, here you can see we are loading the RA register and A0 register from the stack point, and then we are again doing the add immediate instruction. We are adding 8 to the stack point, and then we are doing the multiplication instruction, which is we are multiplicating the value of V0 with A0 and placing the value to the V0 register. Then we are following the instruction jump to the RA register. So you can see this is the code, this is the fact function, and the fact function we have stopped here, and the following instructions are that we are adding the value of V0 with 0 and placing the result to the S0, and this is the you can see the comment here, this is the factorial of n. I have to add that this instruction follows that it will jump and link to the fact function again and again until it meets the base case. Here, when it meets the base case, these instructions are followed and it will return the value v0 and go to the next instruction, and then we will load word the array register from stack point and again load the a0 register from stack point. So this thing will be added again, and then we will add the value of v0 which we got from here with 0 and place the value to the a0 register. By this instruction we are commenting here the factorial of n, and then this instruction means that we are adding the value of s2 with 0 and placing the result to the a0 register, and then it will again jump and link to the fact function. After the fact function, we are following the instruction which is we are dividing the value of s0 by v0 and placing the result to the s0 register. We have found the value of v0 from the fact function, and then we are following the instruction sub, which means we are subtracting the value of s2 from the value of s1 and placing the result to the a0 register. Then we are going to jump and link factorial function again, and from this fact function we have again found the value of v0, and again we are following the instruction which is division. That means we are dividing s0 by v0 and placing the result to the s0 register. Now we will exit from the program by this instruction which is jump exit. You can see here we have initialized the value of n equals to 6 and the value of r equals to 3, which gave us the result which is 20, and the hexadecimal value of 20 is 14. Here you can see we have run the program, and here the value of s0 in hexadecimal is 14. So this is the MIPS code of NCR. Please pardon our mistakes. Thank you everyone.